Okay, in this final section, I want to talk about how to solve absolute value inequalities. Now, here I'm going to give you there's two situations that you need to be able to deal with an absolute value inequality. One of those is when you have the absolute value of an expression less than a positive number. Now, if that's the case, what you can do is, once you've got the absolute value isolated, that's important, you need to isolate the absolute value first. Once you have the absolute value isolated, you can actually write the expression without the absolute value. So right down here, I would get rid of the absolute value and just write what's in the expression. And you place the value of the absolute expression between negative the constant and positive the constant. Okay, so rather than me going over the next case, let me just go ahead and show you an example of that. So right here, I have the absolute value of an expression less than a constant, less than 9. So what I do in that case, the way you solve this, is you take the expression. Notice I've taken the expression out of the absolute value sign symbols, and I've actually got it between 9 and negative 9. So I wrote it less than 9 and greater than negative 9. And then we can solve that compound inequality by just doing a couple of steps. The first step would be to add 2 to all three of these expressions. So I would take negative 9 plus 2, 3x minus 2 plus 2, and 9 plus 2. And that would give me 3x in the middle. So I have negative 7 is less than 3x is less than 11. And then you can divide everything by 3 to isolate the x. And when you divide everything by 3, you'll get negative 7/3 is less than x is less than 11/3. So basically the solution is all values between negative 11/3, between negative 7/3 and positive 11/3. And so that's how you solve when you have the absolute value of expression less than a constant. Okay, now let's go to the second case. What if you have the absolute value of an expression greater than some positive number? Okay, well in that case, you actually have to solve two inequalities. You still remove the absolute value, but the first inequality you write is the expression is less than negative the constant, and then you also have to solve the inequality where the expression is greater than the positive constant. So let me show you an example of that. So if you'll look down here at number 2, you'll see that I have the absolute value of x minus 4 is greater than 9. So I have two inequalities to solve. So I lose the absolute value and just write x minus 4 is less than negative the constant. So x minus 4 is less than negative 9. And then the other inequality I'm going to solve is I have x minus 4 is greater than positive 9. So I have to solve both of these inequalities and then take the union of those two inequalities. So here I'm going to add 4 to both sides. So if you add 4, not 5. So got that wrong there. So that's a quick little fix. Okay, so we add 4 to both of these, and you get x is less than negative 9 plus 4. So x is less than negative 5. Now, the other one is x minus 4 is greater than 9. And so if we add 4 to both sides here, we get x is greater than 9 plus 4. So x is greater than 13. So the solution would be everything less than negative 5. So it would be negative infinity to negative 5 union 13 to infinity. Okay, so again, little typo there. It should be a 4 instead of a 5. And so you get x is less than negative 5 here. And then so the solution here is negative infinity to negative 5 union 13 to infinity. So everything in this set plus everything in this set is actually in the solution. Okay, this one is pretty straightforward. It's a less than, but notice I put in an equal to this time. So if there's an equal to with it, you just carry the equal to into your problem. So I have the absolute value of x is less than or equal to 8, and since that's a less than case, I would put the expression without the absolute value, which is just x, between 8 and negative 8, but this time I use the equal to's with the inequalities. So I have x is less than or equal to 8 and greater than or equal to negative 8, and that set in interval notation is just negative 8 to 8 with brackets. And then here's one. Absolute value of 3x is greater than or equal to 6. So again, I'm giving you one with a greater than or equal to. Now, if you go back and look up there, it tells you that when you have the greater than case, you take the expression and write it less than the negative number, and then you write it greater than the positive number. But since I have the equal to with this, I'm actually going to write this less than or equal to the negative number, and then we'll write this as greater than or equal to the positive number, 6. So then divide here, I'm going to solve this by dividing both sides by 3, and I get x is less than or equal to negative 2. And then over here, I'm going to divide both sides by 3, and I get x is greater than or equal to positive 2. So your two sets, when you put them together, is everything less than or equal to negative 2, along with everything greater than or equal to positive 2. So it would be negative infinity to negative 2, union 2 to infinity. And of course, we have the brackets with the negative 2 and the 2, because we have the equal to with the inequality, which tells me that those values are part of the solution. Okay, now the key to solving more complicated absolute value inequalities is to make sure you isolate the absolute value expression, because you can't apply the property until you get this absolute value expression isolated. In other words, get it by itself. Don't even worry about the properties that I talked about until you get that absolute value expression all by itself. So what I'm going to do here, I just copied it down again right here. So what I'm going to do here is, in order to get rid of this negative 2, I'm going to add 2 to both sides of the inequality. So notice on the left of the inequality I added 2, and notice on the right of the inequality I added 2. Now what that does, obviously that cancels the 2's over there. So now I get, on the left of the inequality, I get 3 times the absolute value of 5 minus x, and on the right side of the inequality I get 4 plus 2, which is 6. Now, in order to get rid of this 3, all I have to do is divide by 3 on both sides, and I actually showed that down here. So all I have to do is divide by 3 here, and then 3 over 3 would be 1, and then I have 6 divided by 3 is 2. Okay, so now I've got the Holy Grail. I've got the absolute value isolated on the left. So now I can use the property. Okay, now remember the property for the less than case. The property for the less than case says you take the expression out of the absolute value, and then you put it less than or equal to positive the number, and then greater than or equal to negative the number. And so then we have to solve that inequality. So we want to isolate the x in the middle like we did on some earlier examples. So to get this x in the middle, what I want to do is I want to subtract 5 from the 5 minus x. So I'm going to take a 5 away in the middle, and if I take a 5 away in the middle, I got to take a 5 away on the left, and I got to take a 5 away on the right to keep it balanced. So now I have negative 2 minus 5 is negative 7. In the middle, the 5's canceled, and I just have the minus x. And then 2 minus 5 on the right is negative 3. Now, since I want that to be x and not negative x, I can multiply everything by negative 1. So let's just do that in our head here. But when we do, make sure we remember to flip the signs over. The inequality signs reverse direction. So remember, I'm going to multiply everything here by negative 1. So that's going to flip this less than or equal to a greater than or equal to, and this less than or equal to a greater than or equal to. Now, negative 7 times negative 1 is 7. Negative x times negative 1 is positive x. Negative 3 times negative 1 is positive 3. Now, remember earlier I told you that when you have an answer like this, you generally want to write the smaller number first. So let's read this right to left. That says 3 is less than or equal to x is less than or equal to 7. So let's write what I just said. 3 is less than or equal to x is less than or equal to 7. And so there's your solution set. And in interval notation, you would just say 3 to 7 with brackets. Okay, let's do this one. On this one, same concept. I want to isolate the absolute value expression. First thing I want to do is get rid of this minus 5 right here. So I'm going to add 5 to the left of the inequality and 5 to the right of the inequality. And so if I add 5 over here, it's going to cancel the negative 5. And if I add 5 over here, I'm going to get negative 8 plus 5 is negative 3. Then, in order to get rid of this negative 2, remember what I have to do? I have to actually divide this by a negative 2. And remember, when you divide by a negative number, so I'm going to divide both sides by negative 2. And when I divide by a negative number, remember this flips from less than to greater than. So that's going to flip it over. And so I'll get the absolute value of 3x minus 6 is greater than positive 3 halves. Now, this is the greater than case. So remember what I said about the greater than case. You have to solve two inequalities. So for the greater than case, greater than a number, you take it out of the absolute value and write the expression less than negative the number. So it would be less than negative 3 halves. And then you take it out of the absolute value and write it greater than positive the number. So it's greater than positive 3 halves. And then we can solve each of these by just adding 6 to both sides and then dividing by 3. So here, if I add 6 to both sides here, I don't know why I wrote that twice, but anyway, if I add 6 to both sides here, I get 3x is less than negative 3 halves plus 6. Now you need to convert 6 to get a common denominator. Remember, 6 is 12 over 2. So minus 3 halves plus 12 over 2 gives me 9 halves. So now, in order to get x by itself, you're going to divide both sides by 3, or if you prefer, like I do with fractions, multiply both sides by a third. So multiply both sides by a third, and you get x is less than 3 halves. Now I'm going to solve this one the same way. Just add 6 to both sides, and then I get 3 halves plus 6 over here, and 3 halves plus 12 halves is 15 halves. Then divide by 3 on both sides, or multiply both sides by 1/3, and 1/3 times 15 halves is 5 halves. So the solution is everything less than 3 halves plus everything greater than 5 halves. And this is how you would write that using interval notation. Now the last thing I just want to mention real quickly, there are, in some absolute value inequalities, the solution is so obvious that you might not see it. So if I said solve the absolute value of an expression is less than a negative number, well, you know the absolute value of an expression can't be negative, so how can it be less than a negative number? So in that case, you can just say, well, there's no solution. Anyway, if you go back and look at my properties that I gave you, I said the properties only work when this is a positive number. So you can't apply the properties there. And here's another example. Here it says the absolute value of an expression is greater than or equal to 0. Well, isn't the absolute value of any number always greater than or equal to 0? So in that case, it wouldn't matter what number we chose. Any number would work there. So the answer there would be all real numbers. Okay? All right, well, that completes this chapter I did on linear equations and linear inequalities. And so hopefully you got a lot out of this. Good day.